Hey everybody, Lars here. Time for the first review video for Big Bad Unit 5. Only Big Bad Unit 5 isn't so big and bad. It's 3 weeks, so we have a lot of time to go over a kind of a new concept. We're going to start talking about object-oriented programming. And when we usually get to this stage, I tell the story about different ways of writing programs. Back when computer science is in its infancy in the 40s and the 50s, we're creating machines for war purposes. Turing is creating the bomb to solve codes at Bletchley Park. And John von Neumann is here in New Jersey, in Princeton, building different machines. And back in those days, you were writing programs just for the machines they were going to run on. Would work on only that machine. It was programmed for that machine. Nobody, well, von Neumann did eventually, ever gave thought to writing a general program and then having that translated to the ones and the zeros that a specific machine would know. But then that started happening in the 50s and 60s. We started saying, hey, could we write a general program and then give it to something called a compiler, which would then turn it into the ones and the zeros that the machines understand. And at that compiler level, you could take one program and create ones and zeros for all kinds of different machines. And that kind of computer that worked on that ended up being called the von Neumann architecture. And the stored program, it sounds silly and simple now, but back in the day, the stored program was a big deal because you could write one program and then compile it to have it run on a bunch of different machines. So you weren't writing for a specific machine anymore. At that point, you got some higher level languages, Harvard Basic, late 50s. In the 60s, you got Fortran, which was a popular scientific programming language, Pascal. Now, all of these languages were just like the Python you're learning. They were imperative in nature, imperative meaning commands. You had your data, and then you did a series of commands to get to a goal state at the end. Very similar. If you saw, after this course, if you saw Fortran code or Pascal code, you'd probably understand a little bit of it, because it's what's called structured. And you could see, you set up your data, you had loops, you had arrays, in your case lists, you had functions. Sometimes in the past they were called subroutines. So you had all that stuff. All of a sudden, computer programmers are always tinkering, computer scientists are always tinkering. In the 70s, people started playing around with the idea that I want to create a custom data type. I want to create a data type of my own. And if you know anything about the C programming language, there's something called struct, which allows you to create your own custom data type. Well, people started thinking to themselves, what if I want to write a program and I want to simulate how a bicycle works, or I want to simulate a pool table with billiard balls bouncing off each other. If I want to do something like that, that's, while doable in an imperative sense, it would be easier if I could set up some kind of simulation, some kind of thing where I've described these objects, and then I get a whole bunch of them and put them all together and let them interact with each other. Is there a way I can do that? How can I do that? So people at first would go to C and use structs to create individual data types, and those data types would have certain kinds of attributes, and you would run only certain kinds of functions on them to make them do what they did. And it was kind of like we were faking it at the time. Then in the early 80s, and this is getting in the weeds, but there was a language that came out called Squeak. And Squeak was truly object-oriented. And what that means is that you would create a blueprint. Okay, we're going to call them classes. You create a blueprint for something you want to create, and then you can actually create it and in what's called instantiating it, or getting an instance of it, and then it becomes an object. And the key is that you write that blueprint once, and then you can get as many objects as you want. And they all have to follow the rules of that blueprint, certain kinds of data and certain kind of things you can do with it. Smalltalk, I believe, was the first time. Smalltalk came in around 82 or 83. And Smalltalk was object-oriented. Then, in the late 80s, I think it was 87 or 88, you put a gun to my head, I'll tell you 87, a gentleman named Bjarne Stroustrup, who was working at AT&T, this is where C was invented, and Unix back in the 70s, wrote extensions for the C programming language in order to do object orientation with it. And that became C++. So whenever you hear C or C++, C++ is what's called a superset. It encompasses all of C. So when you do something in C++, you can also go down and do things the old-fashioned way in C. C++ was one of the first times where people started saying, hey, we're going to use object orientation. And a lot of people went out and rewrote their code. There was a complete rewrite of the Windows operating system at the time to use C++, and a whole bunch of people ran out and did it. Then, about 7 years after that, in 1995, Java came out, and Java was completely object-oriented. It's not like there were just extensions to allow you to use object orientation. It was object-oriented. You were not getting around it. You had to do things with classes when you did things with Java. So the idea of object orientation, like I explained it before, is that you create blueprints. They're called classes, and what they do is they group together the data and the functions you can run on that data. But for whatever reason, in an object-oriented context, we don't call them functions anymore. We call them methods. So whenever you hear the word methods, we're really talking about functions. But we're talking about functions that are in a class and can only be run on that particular data. Okay? So we're going to take that blueprint, we're going to get a real object. And that object is going to have each individual data point that was described in that class. Those are called instance variables. And you can only do certain things to them depending on what you describe. Now, this all sounds abstract and hokey and kooky. So what we're going to do, I'm assuming you've read the slides or you're a little familiar. If you haven't, go read the slides first, then come back. Object orientation, in my mind, is best conveyed with as many examples as possible, and then you work through those examples and you see what's going on and how it's going on. So your slides, you got the dice. Okay, so you got the dice example. Then after that, I think I do the student record from the Zell book and some other things like that. Today, we're going to completely switch it up, and what I usually do at this point is we create a class for a checking account. And then we're going to get a bunch of different checking accounts, and I'm going to show you how the behavior works. So I am starting from scratch. Wouldn't kid you. New file. All right, so let's give myself some comments, not a whole bunch. I'm just going to say checking class up there on the top. And the first thing I'm going to do is I'm going to create my checking account class. Keyword class. Okay, I'm going to call it checking, colon. And then I am going to create the first, and some would say most important method that a class has. Whenever you instantiate a class, whenever you say give me an object from this class, there's a method that gets run, or a function that gets run every time you create an object, and that is called the constructor. And in the constructor, you do what you want to do when you create that. Constructors have special names. Those are double underscores. Python programmers call them dunders. Okay? So the name of a constructor in Python is dunder, init for initialize. Dunder. So dunder, init, dunder. Sounds weird, but welcome to Python. Is your constructor. And what I'm going to do is I'm going to type the keyword self. Well, it's not a keyword, you can see. And we're going to explain that in a second. Think of it kind of as a placeholder, something that points to itself. And we're going to say amount because we want to give it an amount when we create it, and you're going to see that. And basically all I'm going to do is I'm going to say print, you have created a checking account. And then I'm going to create a variable. I'm going to say self, and I'm going to call the variable balance. I'm going to make it equal to amount. And that's it. Okay? That's all I'm going to do when I create this object. I'm going to say you've created a checking account, and then I'm going to set that variable balance equal to amount. Okay? Now, there's a convention that we have when we use object orientation, in that whenever we have a instance variable, and we set one right here, we usually have two methods for it. One's called a getter, and one is called a setter. So that when I'm using the object, if I ever want to get one of the instance variables, I can run a get method and have the value sent back to me. And then there's another one called a set, where if I want to reset it or change the value, I can use the setter. Now, first thing we're going to do is we're going to create our getter. And what it usually is using Hungarian notation, which is when you start with a lowercase word and then the rest of the words after that are denoted by uppercases. We're just going to put self there. You're going to see why later. And all I'm going to do is I'm going to return self.balance. And that's it. So when I run it, it's basically just going to return the instance variable. And that's it. Okay? That's my, you could even do this if you wanted. I usually never do this. But if it helps, you can say constructor. And then you can say getter. And I'll say getter for balance because you could have more than one if you wanted. Okay? Now, the setter, we're not going to really use a setter because with this particular, look, my OCD is, let your code breathe, son. All right. We're not going to use a setter here because we're doing a checking account, and I'm going to write two methods right now that are going to be used for setting the amount, because I'm going to write a method called deposit, which will increase it if I want to increase it, and I'm going to write a method called check, like writing a check, and that's going to decrease it. So I have official ways to reset my thing. So I'm going to forget the setter for now, and I'm going to write a deposit method, which is pretty easy. I'll say def deposit. When I do a deposit, I'm going to have self, and then I'm going to have an amount because I'm going to have the amount I want to deposit. And basically, all I'm going to do, yes, come in. I'm shooting a video.
I interrupted your video?
Yeah, you did. 12 minutes into it. And forgive me, life intervened there a little while. The perils of doing videos while you're sitting in your office at Rutgers. What we're going to do now, instead of a setter, is we're going to write a method called deposit. And what I'm going to do is I'm going to take an amount. And then for my deposit, what I'm going to do is I am going to say self.balance plus equals amount. And that way I will add the amount. Notice I'm not doing any error checking. I'm not doing anything crazy like that is concerned. And then, you know what? I'll do this. Print the new balance is self.balance. So then I'll print out the new balance after we've done the deposit. Okay? Is that good enough, or should I print out amount? The amount was amount, comma, and the new balance is self.balance. Great. Okay. So we have a deposit. If I want to add money to the account, now I can add money to the account. Now we're going to do the last thing. When you want to get money out of a checking account, what do? You write a check. So what we're going to do is we're going to create a method called check. And what check is going to have is check is going to have self, and check is going to have amount. But check is going to be a little bit more complicated than just decrementing the amount. What we're going to do is we're going to make sure we have sufficient funds first. So what I'm going to do is I'm going to say if amount is greater than self.balance. What does that mean? That means, notice that pregnant pause again? That means we're writing a bad check because the amount we want to write a check for, we don't have that in the bank. So what I'm going to do if I do that is I'm going to print insufficient funds, and then print cannot cut a check for comma amount comma when balance is self.balance. That works. And we get it all on the screen at the same time. Do I? Yes, I do. And let's do that just in case. All right. So we've taken care of the case where I'm trying to cut a check that's too big. But what if, and you can see it takes care of the equal too. It's got to be greater than. So actually I should say greater than or equal. No, equal is fine because equal I can cut that check. So now I'm in the good situation. I'm in my else. I'm cutting a regular check here. So now what I want to do is I want to say self.balance, and I'm going to decrement that amount. And then I'm going to print, you have cut a check in the amount of, comma, and then amount, and then I will print your new balance is self.balance. You know what? I think I'm done. I'm going to say test it. So now I have a class. It's called checking, and it's got 4 methods in it. The constructor, which is run every time you create your object. That's usually where you set your instance variables, the variables you're going to use with that particular object. Forgive me for my coffee break. Then I put a setter in there so we can get the balance. We're going to use that right away. And then I have 2 methods, one to add money called deposit, and I don't do error checking. I'm just going to use good numbers that work. All right, I'm cheating for my little toy so we can learn this stuff. And then the checking. With the checking, I did see if I try to do too much, if I try to cut a check for too much money. So I check it against the balance variable. And if amount is greater than that, then we have insufficient funds. And we tell the people, all right? All right. So what am I going to do? First thing I'm going to do is I'm going to grab a variable. I'm going to call it L account. And what I'm going to do is I'm going to assign it the variable, the class checking with $300. Now, you know what? I'm feeling rich today. I'm going to give myself $500. Okay? So that line right there creates an object. L account is now a variable that points to an object that was created with the checking class. We're going to get back to it in a minute. Right now, I'm going to print L account dot get balance. Remember, get balance is a function. It needs the parens when you call it. And what this should do is create my object. So it's going to print you have created a checking account. And it's going to get my balance, which should be 500. So it'll print 500 to the screen. If the gods are with us. I haven't even saved this thing yet. What in the name of heaven is that? So what I want to do is I want to go up here and I want to go to Python Data Science, and I want fall 2018, and I'll grab hybrid, and I don't want to do that. I want to, let me do this, U5-1 vid, and I will call this checking.py. I want to save it because I'm going to put it up for you guys later. All right, so now checking.py has a name. I run it. Hey, no typos. What do you know? No typos. You have created a checking account, 500. Let's trace through this code, all right? Like a function, these are comments. They get ignored. Like a function, when Python sees class, puts everything in memory. So literally, this whole class is put in memory, just like it was a function. Tested as a comment, literally the first thing we look at is the second to last line. L account is a variable. It's assigned the class checking with a value of 500. So what happens? I look in memory. Do I have a class called checking? I do. So with the value 500, I run the constructor. Self is the thing itself. We're going to deal with that in a second. Amount is 500. Okay? So I print, you have created a checking account. You have created a checking account. And then I take self.balance and I assign it amount. So it's assigned 500. All right? That's it. That's done. L account is now a variable name that points to the object that we just created. All right? So I go to the next line, print L account, and then I run the method. And the way we do that is with the period and then the name of the method. You've been doing that all along. You just didn't know it was object orientation. You were doing that with lists when you did append. You were doing that with strings when you did replace, or you did split, or you did that. In Python, those things are classes. Go back and do a type on int and float and list and all that. What does it come back and say? It says class int, class float. Okay? Class list. It's a class. at the end. So now you understand what is kind of going on with that. We call a method in our object by referring to the variable name dot and then the method name. So I say get balance. So what's L account? L account is a variable that was created with the checking class. So I go to the checking class and I look for a method called get balance. So I have class checking up here. Do I have a method called get balance? I do. And what does it do? Return self.balance. Well, when we ran the constructor, we set self.balance equal to 500. So I should print out 500, which I do right there. Okay? So that's kind of how we're rolling. Now, the whole point about this is my buddy Bob wants a checking account now. And Bob's got more money than me, so I don't like Bob. Print, I'm going to say B account dot get balance. Okay, and when I rerun this, now I've run it again, but Bob has 600. L account and B account are pointing to different objects. That's the point. Checking is a blueprint. It's just a blueprint. Okay, we have to instantiate and get objects, and we can have as many as we want. And that's the idea. You can get as many objects as you want and have them play off each other and do different things. Here we have Lars' account, my checking account, and I've got $500, but now we have a Bob account. And Bob has 600, and we can do different things. Think about a bank. How many checking accounts are there? There's a bunch of them, right? And they all pretty much do the same thing. That's kind of the system that we're trying to simulate here with our object-oriented program. All right, so I am going to, actually what I'm going to do, I think, is I'm going to Zotz Bob out ever so slightly. I'm going to leave it there because I'm going to put this code up for you at the end of this video. And what I'm going to do right now is I'm going to play around with my account. And I am going to say deposit, and I'm going to give myself some more money here. Let's see, I have 500. Let me give myself $400. Wouldn't that be nice if life worked that way? And then I'm going to, let me steal this. And when I do that, actually, deposit tells me what my new balance is, so I'm not going to bother doing that. I'm just going to run it. And it's going to say, you have created a checking account, 500. The amount was 400, and the new balance is 900. All right, instantly, I don't like that. The amount was blah. I don't need that. And the new balance is that, but what I'm going to do here is I'm going to say print, you have made a deposit. And that, to my mind, is going to look better because now when we run it, you have created a checking account, 500. You have made a deposit. The amount was 400 and the new balance is 900. If I wanted to, I could do the previous balance, whatever, you guys get it. Okay, so I've just added. All right, if I want to go see my balance, I can use this line right here, and I can go look at my balance, all right, and see that my balance is 900. So I'm still in pretty good shape, all right. We finally got to the point where we have enough code that we're going off the screen. That was going to happen. It always happens in programming classes. When you start to get more complicated and you start doing more things, eventually you're going to have to go up and down and you're going to go off the screen. We're officially off the screen. That's a good thing. It means you've done a lot of work. Okay? So now we're going to do one more thing. We're going to test our check. All right? And I am going to say check. And I'm going to write myself a check for $1,000, which I know is bad. That will blow up in my face 50 ways from Sunday. You need to tell it the object you're running the method on. If I just did check, you'd get a, well, look at wonderful idle telling me what I can run. See how it has my variable balance? We'll look at that later. And all of my methods, check, deposit, and get balance. Okay, it doesn't list the constructor. So now when I try to do just check, what's going to happen? It's going to tell me to pound salt. Insufficient funds. Cannot cut a check for 1,000 when balance is 900. Why am I putting all these things in here? Cannot cut a check when balance is 900. All right, so that works. All right, so now while leaving that there, let's say L account dot check, and let's do something reasonable, and I'll cut a check for 500. So after getting told insufficient funds, dun, 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 it almost makes me happy because when things go right all the time, then you can't go correct things. That was just a typo. I forgot the A, but so not the biggest mistake in the world. All right, now I've cut a check in the amount of 500. My new balance is 400. So basically, I've got what I need for a simple checking account here. I did my constructor, and I created the amount, the balance variable, and I put amount in it. And then I have a getter, so I can see my balance whenever I want. It's like using my card or going on the computer and getting my balance. I have a deposit, and I have a check, and I can cut a check. I can't cut a check for more than I have, okay? But I didn't do a lot of error checking, like what if for amount I gave it dog or something dumb like that, you know? I didn't do a ton of error checking, all right? We're going to do one last thing. Actually, we should do two last things. I am going to leave this here because this is the code that I want you to see when I put this code up on Canvas for you. Forgive me if I say up on Sakai because I've been teaching this class for 3.5 years using Sakai. And this is the first go-round with Canvas. And I know we're going to be staying with Canvas from now on, so I'm trying to train myself to say Canvas. And if I forget, sometimes you're going to have to forgive me. Okay. Just for S&G, I can show you that L account dot. Well, first, and I've done this before in previous videos, it'd be nice if we had L account. So I'm going to say checking 500 and create L account. If I want, I can just say print L account balance, and it says 500. Okay, I'm bypassing the getter. I can do that because what you're going to learn when you move, if you move on to more programming things, is that there are actually, I guess you want to call it access or security features with classes. They could be public, they could be private, they could be protected. There's different things like that. It gets to something called encapsulation, where you can hide things even from other programmers who use your things. We don't get into that. I got to pick my spots. I got 3 weeks to teach you a little bit about object orientation. I'm not too worried about that. We're going to worry, the next unit, we're going to worry about more important things like inheritance and polymorphism. We're not going to worry about different things. So I make, by default, Python makes everything public. I keep it public. So we don't even need the getter. I just want you to see getters and setters because it's a programming convention. And when you have an instance variable, you usually have a getter and a setter for it. Okay? So there's that. Now, there's also this idea of self. So if I come down here and I say print lcount.self and I run that code, Python says, whoa, object has no attribute self. What's going on? So it's not something I can access from outside here. But if I come up here in the constructor and I throw in a little line that says print self, well, what do we get? We get this right here, main checking object at boom, 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 boom. And it's like, what is that? That's kind of weird. Now, what if I do this? Watch. Think about this. You've been printing numbers, you've been printing variables, you've been printing strings, you've been printing all kind of. What if I print L account? I just created it. I just created the object. But printing it out, what would I get? You get the memory location where it resides. Because when you create this blueprint, you don't know what the actual object is going to be or where it's going to be or what its name is going to be or what variable is going to hold it. You don't know anything. Think about having a blueprint of a boat. You don't know what kind of boat it's going to be or when it's going to be 2 years from now, 3 years from now, what the name of the boat's going to be. You don't know any of that stuff. The only thing Python knows is when it creates it, the object knows where it is in memory. So that's the one thing Python knows. That's what self refers to. It's when you create the object, it's a way to refer to that particular object. Okay? So when you run it, the self is kind of understood for that object. All right? I usually tell people it's the variable name, but it's not. It's the memory location that the variable is pointing to. It's just pointing to that memory location. It's what's called a handle. It's a pointer. It points to that location, and that's where the beast begins. Okay, so at the end of the day, if you print self inside here, and I'm going to Zotz it out, but I am going to leave it there to remind you. That's all it is. It's a memory location to the actual object, and that's all print is too, because right now, that's all it knows. In the third video, in the third part of our slides, we're going to actually show you how to set something up. So when you say print L account, you can actually print something out. You can do something. But I just want you to see that now. So I don't want to confuse you, and I don't want self to freak you out. want you to basically know what it is. It's just a way to refer to the object you're going to create later within the blueprint. All right, that's really all it is. Okay, so what I'm going to do here is I'm going to ZOTS this out. And I'm going to leave this code like this. Does this run properly? It does. And I'm going to leave this code like this. And I'm going to put it up on Canvas for you. So you've had the dice, you've had the student records and the slides. Now you've gotten the checking account. And it's up here in front of you. I'm going to give you this code on Canvas. And I want you to start forming that idea of what a class is, what an object is, what the methods are that run on those different things. This is the end of the first video, but when we come back for the second video, we're going to create an animal class, and we're going to do some things with what's called inheritance, where you can inherit what a class does and use it with another class. We're going to have an animal class, and we're going to create a dog and a cat, and we're going to do some different things, but I want you to get the basics down. You have a constructor, which is the method that is run when you first instantiate the class and get an actual object with it. When you have variables, instance variables, in this case balance, you have getters and setters. You have ways to get that variable and you have ways to set that variable. And then you have the different methods which basically define what we would call the behavior of your particular object. Objects have two things, attributes and behaviors. Your attributes is usually your data, and your behaviors are your methods, or what you would do with it. And in a checking account context, you have deposit. I can add money, okay? Or I can cut a check, or I can write a check. Do things like that. So in this little case, we kind of faked a checking account really quick. All right? All right, then I'm going to get out of here. You be good. Keep an eye out for that second video. Keep reading the slides and keep doing what you're doing. All right? All right, you be good. I'm out of here.